Okay, this is the third time I will be recording this. I screwed up twice, and so did not have a video to give you. Alright, so when you start up Unity, you click your shortcut, you should see something like this. It's likely, if you haven't really started up the project before, this list will probably be empty or it won't have the project in the list. So you're going to go up to here and click Open and navigate to the project folder, and you can just click Select Folder. It'll probably take a moment to open, especially the first time that you do it, because it has to build a cache. Mine hopefully won't take too long because I've had it open before. It just has to recompile anything that it needs to. And we get it opened up. So by default, Unity should look something like this. You can move things around quite a bit as you kind of just get used to how your own personal workflow works. I'm going to talk a little bit about these different panels and what they are. Over here you have the hierarchy. This is basically shows you what game objects you have in your scene, and that's sort of the gist of how everything is broken up in Unity. You have game objects that have components, which are how you create behaviors. So this is where most of my work lives, is in these components. And so when I write code, I create a class and then I add it to a game object as a component. And game objects, of course, can reference each other and can do all kinds of things to each other, depending on how you write that. Also, so this is showing me all the game objects that I have in the scene. You can have different scenes. So you can, for instance, it's really common to have a different scene for each level in your game, and maybe a scene for your main menu that connects all of those levels. And there's a lot of other ways that you can use scenes to split up your game in different ways. Most likely for our project, each level is going to be a scene, so it should be pretty simple. Aside from the game object hierarchy, you have the inspector over here that I've kind of been pointing at as I click on these things. When you click on a game object in the hierarchy, it shows its details in the inspector. Each of these things is called a component, and if it has this little C# thing, that's a code component, which may or may not be something I wrote or something I imported. If it has something else, then it's likely to be a built-in Unity component. For instance, this box collider is a collider component that's built into Unity. Transform is a built-in component that is, by default, every single game object requires a transform component. And up here you can enable and disable the game object. If it's disabled, it doesn't appear in the scene. None of its scripts will execute, and it won't receive messages, stuff like that. It's basically just essentially non-existent when it's disabled. Although you can have hard references to it so that you can write code that will enable game objects, and so you can toggle things off and on and stuff like that. This is just the name of the game object. There's a bunch of other stuff here, but most of this is not very important for you, except for the layer. I'm going to talk more about layers later, but essentially this is a way to kind of bake a little more information into your game object about how it's meant to behave or how it's meant to be treated. And so, the enemy layer, all of the enemies in the game will be on the enemy layer, and so we can, through code, if we arbitrarily run into some object, we can check what layer it's on, and we can make decisions about how to treat that object. Down here you have the project pane. This is essentially just a folder view of everything that's inside your project folder. Yeah, I mean, that's basically it. For instance, if you want to delete a file or something, it's best to do it from within Unity because it has meta files that have information about just where it's located, and if game objects in your scene have references to files in here, then you want to delete it in Unity so that it knows to notify that game object that item has been deleted. Otherwise, you just get missing references and stuff, which isn't a big deal, but it's a little cleaner if you do things from inside of Unity when it comes to deleting things. If I go into Windows Explorer and I add a file in here, the next time that I focus Unity, it'll import it, and it'll create a meta file, and it'll do all that stuff. So adding files through the Explorer is fine. Now, then you have the console, which you probably won't really need to mess with. This is how you debug log messages. So if I'm having trouble figuring out why something in my code isn't working, I can print values to this log, and I can track values and do various things in here. But this is more a coder's tool, generally speaking. And then up here is the scene view. This is kind of what it sounds like. It's a view of the scene that you're building. You'll notice this 2D button here. If I click that, it shows me the 3D view, but we are making a 2D game, so we should never really have to do this. So just make sure that that's always set to 2D so that you're not moving things around on the Z-axis, because we don't want to do that. And then you have the game view, which this is, the game window is the actual, what the game looks like when it's running. So if I hit play, this is the game. I can force it to be a certain resolution. Right now I just have it free aspect, so it just fills this window, but I can set it to 1920 by 1080, and it'll sort of like scale it down to fit in here. I can also change the scale, in which case it does its best to, it crops out what you can't see at that scale. You'll also notice that if you're working in the scene view and you hit play to test something, it will focus the game view, of course, which is convenient. Alright, so that's kind of the gist of how Unity works. If you've worked in other game engines, there's probably a lot of consistencies. This component-based thing is pretty pivotal to game development in general, so I imagine that that GameMaker probably works really similarly, although it may be less code-based and more about scripting or doing visual coding and stuff. But the component thing is probably familiar to you. So, all right, so that's a bit about how Unity is set up, and you'll get used to how to actually navigate things. I'm not going to go into every detail about how to use Unity. You'll probably figure out most of it if you're used to similar software. But the way that our particular project is set up, I will get into that now. So you'll notice here I have, probably half of the level actually built in here, and you'll also notice that some of it is kind of less opaque. It's kind of grayed out. That's because I took the outline that you gave me, and I cut it in half because the images were too big for Unity. So I just cut it in half, and I threw those in the scene so that I would have an outline to build the actual working layer on top of it. So if you hide this level outline, you see the actual play layer, or the actual stuff that's gonna stay in the game, basically. This here, this is just a static image with no parallax. I was just using as a guide, so this is not gonna stay. But all of this play layer is done in tiles, which I can show you. All of this is under the game object called level. And don't be too afraid to restructure things if we need to restructure them to make more sense. I used a bit of sensibility when creating these things, but it's possible that some of these could probably just be deleted, or they're just there for convenience sake, or whatever. So if you click on level, there's a bunch of stuff in here. These rooms are basically just boundaries designating where a room starts and ends, for the sake of the camera knowing how to behave, and I'll talk more about that in a minute. In fact, I'm going to create a game object called rooms just to clean this up a bit, and then I'm going to take all these rooms and drag them in there and do that so those aren't in the way. Now, in terms of our actual tile mapped game, our game layer, basically, you'll notice when I click on either of these objects, now you can see a grid, and wherever I hover, my cursor is kind of like, there's a square cursor around my cursor that's snapping to the grid. That's because there is a tile map component on these two game objects. And the reason there's two of them and we might need more depending. The reason there's two of them though is that one of them is called platforms, which is essentially all of the terrain and stuff that the player can collide with. And here I'll hide that so you can see. So that's most of the level is in the platforms layer. And you'll also notice that at the top right here I have the layers set to platforms. So all of everything that I want to be on the platforms layer I put in this platforms game object. And then one-way platforms, you'll notice it's these one-way platforms here. And again, the layer is one-way platforms up here. And the difference is that layer of one-way platforms versus platforms, where is it? Right here and here. That is how our character controller knows whether or not they can pass through those. So, you know, a platform like this, when you're playing like a Mega Man style game, or really just a side scroller in general, you expect to be able to jump through the bottom of it and then land on it, which is a very different set of logic compared to this terrain here. You would expect to kind of bump your head on the bottom of this terrain, and so that layer is what tells our character controller whether or not it can do that. So everything that we want to behave that way, we would paint inside of the one-way platforms tile map, and then everything else that we want to be solid terrain, we would paint inside of the platforms tile map. And then we might have a separate tile map for something else. I can't think of an example of what that might be, but you can imagine, you know, we might have a separate thing for animated tiles, or if we wanted to have animated effects overlaid on top of other tiles, we might have a separate layer for that. But for now there's two layers, platforms and one-way platforms. So I'm going to talk a bit about how this tile map stuff works. It's pretty sensible, but there's a few kind of like a hierarchy that I need to explain. And in fact, I'm going to move my inspector over here. I recommend having the inspector next to the hierarchy. It makes it a lot easier when you're dealing with the tile maps and stuff. And really, in my opinion, it just makes a lot more sense. The scene view doesn't really need to be in the center of the screen, in my opinion. But yeah, so I'm going to move my inspector over here. So you'll notice this tile map component has a tile palette, and this is basically the tile sheet that you provided me, right? And it is split up by tiles, and it knows how to do that. Let's see, where is it? Map? Huh. It should have... That's strange. Oh, that's right. So the tile map component points to a tile set, which this plugin that we're using, it's called Super Tile Map Editor, and this plugin has a few different basically components that are built into it. And at the highest level you have a tile set. Now a tile set is pretty much literally just a pointer to the actual tile sheet component. So I'll click on this and you'll see in the project view it highlights down here to show me what that is. This is the tile set. So if I click on this, it has the texture that we're using as the tile set, which is the texture that you gave me. And so you could, you click this and you could set any tile sheet that you wanted. Then pixels per unit, we are using 32 pixels per unit on all of our sprites, so anytime you import any sprite it needs to be 32, which should happen automatically for the most part. And then the tile size is 32 pixels by 32 pixels. And if you change this, you want to click Slice Atlas, and it will create this grid, and it treats each item in this grid as a separate tile. Makes sense, right? So that's basically it for a tile map, but there are some, like I said, there's a hierarchy of components. So at the highest level you have the tile map, and then the things that compose that tile map are individual tiles, right? And so I can go to my tile map. Sorry, at the highest level you have a tile set. A tile map is essentially just an instance of, it's basically just a layer in your game that uses the tile set as its as its source of art, essentially. Um, so this tile map component uses the tile set, and I can just click in this tile set on any individual tile, and I can just paint these. And you can imagine that makes it much easier to build things, particularly because if you look closely, you can see this red outline around the tiles. That's the collider. So when I paint like this, it knows how to create a collider out of this, which is a huge time saver because I can literally be in the middle of play mode and I can switch over to my scene view, I can paint something, and then I can switch over to game and I can jump on top of it. So it makes it much easier to prototype things, especially if you want to have, you want to have two platforms that are, it's a really tricky jump, like maybe even a pixel perfect jump to reach a secret or something like that, and you really want to test it out and make sure that you've got the right distance or whatever, just whatever piece is particularly satisfying. And this helps you do that. The only drawback I will mention is that it's just a kind of a quirk, I guess, of Unity. It's purposeful, but it's important to note that when you're in play mode like this and the game is actually running, any changes that you make when you are done, those changes are reverted. So changes in play mode are completely temporary. So while it does help us design, you kind of have to, design something, take note of it, and then undo the play button and repaint it in there. So that's just a pitfall to avoid. So you'll notice that these tiles here, this is really simple, right? Because if I paint a single tile, it's just making the collider the entire tile. But for instance, this tile is, the collider goes halfway through it because half of the collider is transparent, or half of the tile is transparent. To make that the case, all you have to do is you right-click in your tile palette on an individual tile, and you can see the properties of this individual tile. And there's a few things here that you can change. There's some grouping logic for how it auto-tiles with other tiles, which hopefully you won't have to worry about too much. Parameters, which you can, again, you probably won't have to worry about, but it's just a way to give tiles some additional information that you can access in code. Prefab, which you can basically create prefabs in Unity are like kind of like a blueprint game object. You basically create a game object and save it in your project, and then you can create copies of that game object. So this is basically this plugin's way of allowing you to take a group of components and put them on an individual tile wherever that tile exists. So for instance, the one place where I'm using this prefab functionality is making tiles that if you touch them it kills you. So like the spike tiles in this tile set here, if the player touches them, it kills the player, and I'm doing that with a prefab that just has a script on it that checks for a collision and then kills the player. And then the final tab is the collider. So you'll notice this tile here, you can set this collider however you want, but of course I have it set to actually match the terrain. And if I click to a different one, you can see that the colliders match the terrain. And if you ever need to set this up, it's actually much less tedious than you would think, because you can select groups of tiles. So like I could select all of these tiles, and these are all, they should all have a full collider, and then I can go in here. That's weird. I guess I have to, oh, it's because I have it set to full. Okay. But I could select all of these, and I could change their colliders, and it changes it for all of them. So it's really not bad, and you can change it on one, and then you can hit copy collider data down here, and then you can select a bunch of tiles in here and hit paste, and it it does what you would expect. It copies the collider data and pastes it into another tile. So this collider stuff, like I said, just makes makes building levels so much easier. Having to make changes and then go in and change the colliders of everything would just be so time consuming. And even just for prototyping levels, I imagine that we might want to consider for some levels, like let's say when we get started on the next level, you might want to prototype the actual movement of the level before you start thinking too much about the visual design. And we could do that by just having a really basic tile set that has a couple of different shaped blocks and just paint out an entire level and actually play through it, maybe with some really basic enemies, and prototype the gameplay first if we want to, and then figure out how best to make the visual design complement the mechanics of that level. So really useful stuff. The next thing after tile set and individual tile is brushes. And there's a few different types of brushes in Super Tile Map Editor. I'm not going to talk about all of them, but I am going to talk about the two that I primarily am using right now. We might end up using all of them, but the two that are really powerful are the carpet brush and the random brush. And the interesting thing about these brushes is that you can sort of nest them within each other. So let's see, a carpet brush essentially, let me see if I can find, yeah, okay. So this is, if you click on a carpet brush, or if you right click, go to create, Super Tile Map Editor, brush, and then carpet brush, that'll make a new carpet brush. Call that test brush for now. And when you create a brush, you have to give it the tile set that it's supposed to point to. And then you'll notice for this carpet brush, there are 9 squares here, and then there's 4 more squares down here. And the way that this works is, for instance, let's do for the, so for the top left, I'll do that one. For the top, I'll do this one. For the top right, I'll do this one. For the center, I'll do this. Okay, now if I go to my platforms layer and zoom in a little bit so we can see what we're doing, I'm going to click import all brushes found in project to get my new brush. I'm going to click display list because I like to see the names. And then, what did I call that? Test brush? Yeah, okay. So now this brush, it's kind of a smart brush. It knows what tile is meant to be placed where. So all I have to do is paint, and it saves me the trouble of having to go get the top piece, go get the left hand piece, go get the right hand piece, and so on. And it fills in the center with the center pieces that I gave it. You'll notice that if I do something that juts out, it behaves really strangely. That's because I haven't set these inner pieces here. And in fact, I think we would actually need new tiles for that, because I don't think it behaves very friendly unless we have different shaped tiles. I haven't concerned myself too much with that, because none of the level design that we have so far actually has, like indentations like this, so it's not really an issue. But yeah, you'll see anywhere that you have sort of like pieces that stick out, it uses those other 4 squares instead. Now, this obviously, even though it's saving us a lot of time, not having to go back and forth between the tile map and the scene here to paint, this obviously looks terrible because this middle piece is always the same, the edges are always exactly the same, we have the same repeating thing up here, it just looks really terrible. But what you can do is create Super Tile Map Editor brush, random brush, and you can make a random brush is basically, we'll give it a tile map, it's what it sounds like. You can give it, a few tiles, and yeah, sure. Go to your, let's see, import, I have a new random brush, and it'll just randomly choose between the 2 tiles that I gave it. Right? that isn't particularly useful on its own, but when combined with a carpet brush, it's amazing. So I have this dirt brush here. It's just called dirt. I should probably rename it to like smart dirt brush or something like that, just so that it kind of stands out, because generally speaking you're never going to use these other ones. This is like what you want to use almost always. And the way that this works, if I can go to it, here it is. It kind of looks like it's set up the same way as the test brush that I created, but what it's actually doing is the several of these are actually random brushes. So this top piece here is, I forget, it's dirt random top, and this one has all of the different top pieces. It has an even probability for each one, and so if we look at our dirt brush, this piece here is actually a random one of these top tiles. And so when I use this brush, as you've seen already, like I said, there's weirdness if you create gaps, but if there's no gaps, it creates terrain just like that. And a nice thing about this too is that, you know, sometimes when you're painting, it'll sort of randomly do a combination of things that is not very attractive. You can just paint back over it, and it'll kind of re-roll that tile. So yeah, let's say I don't like those big ones in this area, so I want to like repaint and make it a little more plain. You can just do that, and it's fine. You can also, for these random brushes, you can toy with the probability. So if you have particularly interesting features in a specific tile, so much so that you don't want that tile to repeat very often, you can just pull down the probability, and then when you're painting, you don't have to undo those when they come up too often, because you know you really want it to come up 1 out of every 100 times or whatever. Then just set the probability to 1%, and then if we get to the late stages and we really want to like carefully handcraft each individual tile, we can go in and we can you know, add those details as we see fit. So I made a big mess out of this tile sheet, but that's okay because I can just revert it in. Oh boy, I did not mean to do that. I can just revert it in version control, and in fact I'm going to do that right now. So in my project and version control here, or in Tortoise HG, I can update, discard local changes. Actually, I should make sure I didn't do any other work on this before I do that. I don't think I did. Oh man, my computer's freezing up. Okay, I have a ton of uncommitted stuff. Yeah, I'm not going to do that then. I will just... Where's my scene? It's called main. Huh, that's weird. Why is that not showing up? Huh. That's really... Oh, it's because I haven't saved it. Oh, I guess the easy thing to do then would just be to reopen the scene, say don't save. Alright, back to where we started. Okay, so that is kind of an overview of what you can do with Super Tile Map Editor. You've got your tile set, then you've got your individual tiles, and then you have brushes that are composed of individual tiles. And brushes can also be composed of other brushes, which is, I think, is where the real power comes in. So now that we've covered the tiles a bit, I'm going to talk about the room boundaries, and I'm going to talk about parallax background elements and how those are set up. So the room boundaries, I might do some reworking of this. I think the principle makes sense. I think there are some bugs with it that need to be worked out, but hopefully the overall idea works. And if you think maybe there's a better way that we could do this, let me know, because I'm open to ideas about how we could do this. I'm going to recreate my rooms game object, move all these in there. Oops. Okay, so as I click through these rooms, wait, what? That's weird. It should show me the collider of the room. Why is it not doing that? Huh. Oh, because I had it closed? Oh, I didn't know that it did that. That's cool. Okay, so if I... Alright, as I click through these rooms, you can see it's showing me where each of those boundaries are, right? And I'm about to sneeze, sorry. Whew, okay. So if basically all these rooms are doing are constraining the camera and or the character. And so for the first room, you can see that our room component that I created has basically four properties defining how the camera and the character interact with that particular boundary. So for the left wall, we want to clamp the camera and we want the character to collide. And the reason for that is because when the level starts, and let's say, oh, that's not a great example, you've got the camera lined up like this, you don't want the camera to be able to go past this left boundary because you don't want to see this ugliness here, and you also don't want the player to be able to fall out of the screen and fall to their fall into oblivion over here. So I set the left wall to clamp camera, I set it to collide with the character, and then you just kind of do the same thing for the right wall and the ceiling and the floor. And so on the right wall over here, I set it so that the camera is clamped, so when you get to this point here, the camera will stop moving and the player jumps on these platforms, and then when the player hits this wall, they are unrestricted. So they're able to just walk out past where the camera can go. Now, this room system is set up automatically so that when the player walks out of here and enters this next room, which is room 2, that becomes the current room, and so the camera will snap into this room. So rather than having the camera, follow the player into this area, instead the camera's going to stop here, and when the player reaches this edge, the camera's going to snap, and then the player is in this room, and we follow the rules of this room. And so that's just generally how it works, is whenever the player touches a new room, that room becomes the boundaries for the camera, and that room's rules are what the camera respects. So you can have a room. Actually, honestly, this is the last room that I have set up in the scene, and you can continue going past this point. It's just that when you get to this room, I set all of the restrictions to none, and basically that means that once this is the current room, the camera can follow the player everywhere. Of course, when we actually get this totally set up, we're probably going to have another room here and another room, and we're going to keep adding rooms wherever we want there to be camera boundaries and or player boundaries. But just so that I could sort of play test the actual tile placement and everything, I just set this to unrestricted so that I could get to this point, and then I wasn't too worried about setting up every single room all the way to up here. So hopefully that makes sense. I know it's a little unusual. Basically, when you're building these levels and you want to set the camera restrictions, you can just take the most recent room, Control-C, Control-V, or right-click duplicate, whatever you want to do, and then in your scene view here, take your duplicate, which should be right on top of the thing that you just duplicated, switch to the transform tool, and you can slide this around, and then on the box collider, this is the boundary that's being used. You can say edit collider, you click on that, and you can just drag this and change the shape however you want, and then just make sure that you update these rules to reflect what you would expect in that room of the game. And that's pretty much it. So now you'll notice there's some overlap that is probably not a good thing, but depending on the rules of the camera, it might not really matter. But yeah, you'll just need to be sure to add these rooms and set them up, however we think is best for a given scenario. I know that some of what I've set up is like not great. There's some weird transitions in places just because it takes a little bit of trial and error to figure out where a good camera transition is. And really, we can ask ourselves whether we even really care about that. We could really simplify things by just having, very few areas where, like in the beginning here, it makes sense to an extent because we don't want them to be able to see over here. But if we fill in all the background stuff, we don't really need to restrict the camera. But at the same time, it might be more natural to restrict the camera because that's kind of just what people expect when they play games like these for the most part. So yeah, that's how the rooms work with the camera system. And then the last thing that I wanted to cover is the background elements and the parallax. So you'll notice inside of this level game object here, I have a few objects. It might even be best to create a let's see, I'll call this like parallax. I don't want to call it background because some of it is actually foreground. Do that. I think that's good. Now, we've got a few layers here. I might actually hide some of these just to simplify explaining. Yeah, so we've got this background layer here. Wow, that's huge. Okay. And basically, this is just a top-level game object with this component on it called parallax element. And underneath that is the actual images that we want to be parallax. And so, there's actually a ton of them because I put a bunch of them inside of this trunk object here, which is just an empty top-level game object. Now, if you want to, basically, you can think of each of these like sort of top-level game objects that have this parallax element script. You can think of these as layers in the background / foreground, and so every sprite inside of this game object will move at the same speed in the parallax. And if you want to have more layers, you just create another. You could even duplicate this and then just delete its children, or you just create empty, add component, parallax element, and you set your own custom speeds for these things and whether you want it to move in the opposite direction. By default, I having them move in the opposite direction of the camera, which I think is sort of the default way that you expect parallax to work, I think. So, so it's really simple to create a new parallax layer. And it's really simple to add new objects to that parallax. So if you go to your project view, let's say go to sprites, I'll go to actors, why not, we'll add a copy of null to our background just for the heck of it. Maybe I should do something smarter. Let's use one of the background elements that you gave me. Yeah, so we got some tree leaves here. I can just either drag this into my background layer and then double click it to see where it put it and just slide it wherever I want it, or I can drop it directly in the scene, then find it in the hierarchy and drag it as a child of that background layer. Either way works fine. It might be easier to just drop it in the scene and then move it, but they each have their own clunkiness. So the only thing that's a little tricky about doing this is that, well, here, this should illustrate my point. When the camera moves, you see those elements moving? So this is where the camera is, and if let's say I have these leaves and I want these to be over here, when the player comes, jumps this gap, I want these leaves to be here. The problem is, when the camera moves over there, those leaves are further to the left than I expected. And that's actually not the best example, but let's say for instance that we had a higher horizontal speed for that particular layer, which this is a speed that we might actually use for certain layers. By the time I get over there, those leaves are totally not where I set them. And so when you're designing these background elements, or when you're placing them, when you're designing the level, you kind of have to keep an eye on your camera and move it to the area that you're concerned with, and take those elements and place them with your camera in in the relative area that you want those objects to exist. And then when you go to the next area, you go up here and you drag some more of these in, etc. And these trees are up here. If I move the camera back to the beginning of the level where it sort of belongs, those leaves are in a totally different place now. So just keep that in mind when you're placing these things. Make sure that you have the camera close to where you're placing the background elements, so that they're actually being placed where roughly where you think they should actually be placed. And I'm assuming you've seen the parallax in action, but in case you haven't, I'll go ahead and do that. And so you can see, hopefully you can see anyways over OBS, that these things, do I still have, yeah, I have level outline, yeah, there we go. These trees all slide past each other, and there should be 0.05, which should look a little bit better, but there's different levels of trees in the background, so the distant ones move more quickly past the player than although I guess it should be the other way around. This is why I'm not the designer. So yeah, you can just play with the speed of these things really easily, and just make sure that when you're placing the actual sprites that you have the camera near where it will be when the player actually sees those sprites, so that the parallax doesn't throw things off. And I think that's it. That's kind of the project so far in a nutshell. Those are the major tools that we have in place. So we've got the tile mapping for building the level. We've got the parallax so that we can drop in sprites for the background and foreground. You'll notice the grass here is a foreground element, and I think I just have the parallax set to 0 because this is, you can sort of imagine that this is attached to the ground here, so you don't want it like sliding around at a different rate than the ground moving past us. But you will notice that the grass is in front of our character, and I'd really like to animate this grass, maybe make it react a little bit when the player walks through it, but also, and I'm sure you did this on purpose, this grass kind of looks like a like a sound wave. This would be a really cool thing to have reacting to the music. And I have some basic beat detection stuff in here. I have this beat manager, and right now I just have it turning off and on a sprite at the what do they call that? The impulse. Just when the beat is happening, the sprite is turning off and on. But we could do much more sophisticated stuff than that probably. So having this grass actually look like a sound wave moving to the music would be very cool. So yeah, I'd say in terms of creating levels, we have, at least in their most basic form, we have all the tools that we need. Character creation is still, well, character creation is kind of a weird way to put it, but working on the character and the animation is still just a matter of me cranking away at it, and I might significantly rework how that works at some point if it gets too heavy, but I think the direction we're going is pretty good. Things might change if we decide to do a melee character. I'm actually pretty keen on the idea of doing a more melee based game, and maybe even getting a little more unique with just kind of the look and feel of the game. Not not the look. I think the assets look great, but if Null was a melee character, I think it would feel a little bit less like a clone, just because the way that this is designed with a gun and everything, it's going to be very much a clone. Which I guess I'm not totally opposed to that, but yeah. So that's the project in a nutshell, and I have someone knocking on my door, so that's good timing. And let me know if you have any questions. I'm sure there's things that I glossed over that are going to be very confusing, so don't be afraid to ask. Thanks.